So we're looking here at four or more erosional landforms going on from corries, erects, and pyramidal peaks. We're thinking now about glacial troughs, or sometimes known as U-shaped valleys. Well, they're not always U-shaped, so we'll come back to that in a little while. Truncated spurs, hanging valleys, and ribbon lakes. These last three all appear as features within a glacial trough. Okay, so four landforms we're looking at today. Let's begin by looking at what happens to a valley before glaciation. So imagine you've got a river valley cutting over the landscape, and this river valley typically has this profile, a steep sided valley that is V-shaped. And in this valley, so before glaciation, you have a river that's running down, and you have what's known as interlocking spurs. So these projections of land are called spurs. And here's another one over here, a spur. So individually they are a spur, and together they are spurs. So a spur. And because they interlock, when you look upstream, they overlap. They're called interlocking spurs. This is characteristic of a river eroded valley. Now, the glacier then extends beyond the corrie, collecting ice from different corries from the side as well, and gaining ice mass, forming a full valley glacier. And it starts to look something like this. Here we've got a glacier in the Alps. So this is now during glaciation. And clearly the ice is now cutting through the landscape. It follows the easiest path, which is usually the former river valley of that mountain landscape. But now it's actually cutting through the landscape because ice can't easily move around rock, but actually can cut through the rock. And through processes of abrasion and plucking, the ice actually cuts through the landscape and removes rock and removes those spurs that we had in the last picture. And here we see the Lauterbrunnen Valley in Switzerland, and this is a classic glacial trough. So, glacial trough. And a glacial trough typically has very steep sides, a flat bottom, and a very steep side on the other side. And you can see it makes a very distinctive U-shaped valley. And this obviously has been cut by the glacier. And when the glacier retreats after glaciation, that's where we are now, after glaciation, you get this very distinctive trough shape in the landscape. Sometimes within the trough you'll get a little river. You can see a little river here. Blue, a little river, there we go. River coming through the landscape. And this is sometimes known as a misfit stream. And it's called a misfit stream because it didn't actually cut or erode the landscape. So when you look at the landscape, you think, oh, how did that river cut that enormous valley? Well, in reality, it didn't actually. It's a misfit. It didn't really cut the valley. It's just occupying the lowest area of land and therefore creating a stream at the bottom, but didn't actually cut the glacial trough. The glacial trough was cut by abrasion, that process of rocks embedded in the ice, using the rocks. The guys used the rocks like sandpaper, grinding it down. Rocks also plucked, particularly where there are mounds or things that will allow meltwater to build up because of the extra pressure that then collects around rock particles that have, let's say, a number of weaknesses, and eventually then that water then refreezes around that rock particle. When the glacier moves, it will pluck the rock out and carry that downstream, so or down glacier. Abrasion and plucking working together to shape the landscape. And here we see an example of a glacial trough in England. And this is one of the reasons why they're not called U-shaped valleys anymore. If you notice, this valley is definitely not U-shaped. It's much more wide and open. It still has the flat bottom and the misfit stream. Here's the misfit stream running down the landscape, but it doesn't have those distinctive U-shaped sides. This is the Nant Franken Valley in North Wales. And this valley was eroded, around 10,000 years ago, or slightly earlier. And since that time, since the ice has retreated, these slopes have gradually been broken down by weathering of mass movement. And so let's imagine freeze thaw taking place on some of the tops here, freeze thaw. And you can see actually here, freeze thaw over on the other side of the valley. Actually, some of it sort of crosses the road here. This is the A5, which goes to Holyhead. This scree has been created. So gradually, these processes of weathering and mass movement, which is when that scree kind of rolls down the hillside, have reduced those vertical sides to a really wide open valley. So we turn this into a glacial trough rather than a U-shaped valley because they're not always U-shaped. Just another quick look at what's happened to the truncated spurs. If you remember the first image, we had the V-shaped river valley. So V-shaped, cut by a river. In the glaciation, the glacier follows the same path. It's the lowest point in the landscape, but it creates the glacial trough. The glacier is less friendly to the spurs, if you like, and it cuts its way through the spurs, chopping off or truncating their ends. So these are truncated spurs. And they are characteristic, so they would have projected into the landscape like that, as you can see in the one above. So these are interlocking spurs. Whereas these are truncated spurs. Interlocking spurs, characteristic of a river-eroded valley. Truncated spurs, characteristic of a glacially eroded valley. And you can see there our misfit stream in the bottom again. Few other landforms then. So we've got our glacial trough, and now we're looking at a thing called a hanging valley. So this is Bridal Veil Falls in the Yosemite National Park. And a hanging valley is a valley that occurs on the side of the glacier. So if you imagine this is the main glacial trough. I'm not quite sure, but I think the glacier will probably move in this direction. So this is the main glacier is in the valley in the foreground. We've got a side glacier joining that main glacier. If you think about the massive ice involved here, a smaller glacier is going to have less ice than the main glacier, so the effectiveness of erosion, particularly abrasion, is reduced. So the smaller glacier that's joining the main glacier can't erode as deeply. So after glaciation, when the ice is removed, you're left with a valley which is sort of perched above the main glacial valley, which is cut deeper into the landscape. And usually this ends up with a sharp drop. So the valley is hanging above the main glacial valley. And that sharp drop, where a river might follow that smaller valley, will actually join the main valley via a waterfall. Let me see if I can draw this in the space over here. So let's imagine here's the main glacial valley. But here's the side glacial valley. You've got a smaller glacier forming here. Or formed there. And this is the river running through the smaller glacier, or running through the smaller hanging valley, and it drops in a waterfall and then flows out into the misfit stream in the main glacial valley. So again, the tributary glacier has less erosive power, so it cuts a less deep valley than the main glacier, which has got more ice in it, and therefore you end up with that valley that's hanging above the main one. In addition to that, in these valleys you can also get these things which are ribbon lakes. So ribbon lakes. And this is a famous lake in the Lake District called Windermere. Windermere. Ribbon lakes are essentially over-deepened parts of the glacial trough that can then fill with water. A little bit like the way it works in a quarry, but they're called ribbon lakes because they are long and thin. So their dimensions are characteristic, very long, but quite narrow. So more like a piece of ribbon. Now how do they form? Let's look at this next diagram. If you're looking at this diagram, it's pretty self-explanatory, but I'll take you through it. So the glacier, that's it, moving over from left to right. It's moving over different geologies. It moves over the hard rock first, it can't erode it very effectively, but then it moves into an area of soft rock, and perhaps it's picked up pieces of the hard rock and embedded those in the base of the glacier. It moves over soft rock, you can suddenly cut it like butter, and it basically cuts a deep depression into the soft rock, and then encounters hard rock again, and therefore abrasion and plucking will be reduced. So, so in that depression, after glaciation, the ice is then retreating, and you're left with a lake or a depression that can fill with water, and this will be a long, thin lake. Sometimes moraine, a glacial deposit might form at the end, but sometimes it might just be the rock itself that forms that boundary. One other way a river lake can form, which is not shown in the diagram here, is if a very large mass of ice joins the main glacier. At that point, you might find that the glacier can then increase its erosive power, then might scoop into the landscape and therefore cut a depression that way. But even if the geology is the same, you could have it that way. But simply, this is a good example of how it might happen on the board, just hard rock to soft rock to hard rock.